I'm Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, we will discuss about histogram processing. So in the previous session, in histogram processing, we have learned about histogram equalization. In this session, we will learn about histogram matching. So the topics what we are going to cover in that is histogram matching, that is what is meant by histogram matching, in which cases we will apply this histogram matching, and next procedure for histogram matching. So in order to perform histogram matching, what is the procedure we have to apply, and we will see this procedure relating to one example. Now, so coming to histogram matching, first what is meant by histogram matching, in which cases we will apply this histogram matching. So here is the question: is it possible to modify the contrast of one image based on the contrast of another image? So the answer is here, yes. How we can modify means by applying this histogram matching. So for example, let us have a brief discussion about this histogram matching. So let us here consider two images A and B. Here, is it possible to modify the contrast level of A according to B? So if you consider here A is one image and B is another image, we can modify the contrast of image A according to the contrast of image B. How we can modify means, histogram matching is useful when we want to unify the contrast of a level of group of images. So if you want to maintain same contrast for group of images, then we will apply this histogram matching. So in order to perform histogram matching between the images A and B, first we have to apply histogram equalization for both the images. So how to apply histogram equalization for an image? We have seen clearly in the previous session, that is histogram equalization. So by applying that procedure, to perform this histogram matching between two images A and B, initially we have to perform histogram equalization for both the images separately. Then we need to map each pixel of image A to each pixel of image B. Like this, we have to match all the pixels until the entire image is completed. So we can modify each pixel of A based on B. So this is how we can perform histogram matching, and this is the purpose why we go for histogram matching. So the purpose is, in order to unify the contrast level of more number of images, we will apply this histogram matching. Now, so here, this is the procedure we have to apply for an images in order to perform histogram matching. So here is the procedure. What is the first step here means, we have to obtain the histogram of given image. So we know how to obtain the histogram for an image. So in the previous session, we have seen in the concept of histogram equalization. So following that procedure, we have to first calculate histogram equalization. And the second step is pre-compute a mapped level SK for each level RK. So we have to calculate the value of SK for the given value of RK. So here RK represents gray level. And next step, third step, obtain the transformation function G from the given P of Z. So we will see there is one formula for calculating the transfer function G. So applying that formula, we have to calculate the transfer function for all the values of this Pz of Z. And the fourth step is pre-compute Zk for each value of Sk using iterative scheme. That means until all the gray levels are completed, we have to compute the value of Zk for each value of Sk. And the last step is for each pixel in the original image, if the value of the pixel is Rk, map this value to the corresponding level Sk. Then map the level Sk into the final value Zk. Whatever the value we are getting here is the final value, that is Zk. So in order to clearly understand this procedure, let us solve one problem, example problem, which is related to this histogram matching by applying this procedure step by step. So let us consider this example. So here perform histogram matching for the 3-bit image whose size is of 64 by 64 using the following data. So this is the table given. That means the entire table will not be given. We have to draw it. So in this table, only the value of Rk and the value of Nk, these two values will be given. So here Rk represents gray level and here Nk represents number of samples or number of pixels having the same intensity of gray level. And from this Rk and Nk, we have to calculate P of Rk, which is called PDF, that is probability density function. So the formula to calculate this PDF, because why we are seeing all these means, in order to perform this histogram matching, the initial step is we have to calculate histogram equalization for each image. So we are performing now histogram equalization for the given image having gray level Rk with the pixel number of pixel values Nk. Now, so to calculate this PDF probability density function, that is P of Rk, the formula is Nk by Mn. So here Nk, all these are the values that are given. All these are the Nk values that are given. And what about this Mn values means? This M and N represents the number of rows and columns. So here if we consider the question in the given image size is of 64 by 64. So what is this means? 64 rows and 64 columns. It is arranged in the form of M by N. So if you perform this 64 by 64 operation, then the value what we are getting is the value of Mn. So here if you see 64 by 64, the value is 4096, which is the value equal to Mn. That is, in this 64 by 64 image, total number of pixels will be equal to 4096, and this is the value of Mn we have to take in order to calculate this P of Rk. So what will be here? The first value, Nk is for the pixel which is having 0 intensity. Number of pixels having 0 intensity in that image or 790, which is Nk. So in order to have here Nk by Mn for the first column, first Nk is 790 by, here Mn is 4096. 4096. So 790 by 4096, the value is 0.19. So similarly, we have to calculate for the remaining values also. And the next one is 1023. So 1023 is Nk value by Mn value is 4096. So 1023 by 4096, the value is 0.19. 0.25. And next value is here 850, that is NK. 850 by 4096. So 850 by 4096 value is 0.21. And next NK value is 656. So here 656 by NK 4096 is Mn. So the result is 0.16. And similarly 329 by 4096, the value will be 0.08. And next NK value is 245 by Mn, that is 4096. So the value is equal to 0.06. And the next value is 122 by Mn, that is 4096. So the value of this will be P of Rk, that is 0.03. And the last value is 81. So 81 by 4096. So the last value is 0.02. So like this we have to perform and we have to calculate P of Rk. And next one we have to find is Sk, which is CDF. So here CDF stands for cumulative distribution function. So in order to find Sk, so what is the first value here? First value is 0.19. So we have to take this 0.19 as it is. And in order to find the next value, we have to perform CDF, that is 0.19 plus 0.25. And the result will be equal to 0.44. And to find the next value, 0.44 plus 0.21, the value is 0.65. And next 0.65 plus 0.16, the value is 0.81. Next 0.81 plus 0.08, the value is 0.89. And 0.89 plus 0.06, the value is 0.95. And to get the next value, 0.95 plus 0.03, the result is 0.98. And finally 0.98 plus 0.02, the value is 1. So this is how we have to perform and calculate the value of Sk. And next step is Sk into 7. So the values what we are getting here, the values of Sk should be multiplied with 7. So why we have to multiply the value of Sk with 7 means, in the question they have given it is a 3-bit image. For any 3-bit image, the number of gray levels will be formula 2 power k, which is k represents the number of bits. Here the given bits is 3. So 2 power 3 value is 8. So totally 8 levels will be available and it will be represented from 0 to L minus 1, that is 0 to 7. So here maximum gray level will be 7. That's why here for this we have to multiply with 7. So if we perform this multiplication operation with 7 for all these values, so 0.19 into 7 means we will get 1.33. And next 0.44 into 7, we will get 3.08. And 0.65 into 7 is 4.55. And next value is 0.81 into 7, we will get 5.67. And the next value is 0.89 0.89 into 7 is 6.23, and next value 0.95 into 7 is 6.65, and 0.98 into 7 is 6.86, and the last value is 1. 1 into 7 is 7. So all these values we got are in terms of floating point. So histogram equalization means we have to round off that values to the integer value, nearest integer value. So for 1.33, so we can have the nearest integer value as 1, and 3.08 is 3, 4.5 means 5, 5.6 nearest value is 6, 6.2 nearest value is 6, and 6.6 nearest value is 7, 6.8 nearest value is 7, and already the last one 7 is already it is rounded value. And here we can see all these are the values we got, and that values are called as SK, final values. And here to find P of SK, so what is the purpose of finding this P of SK means, if we see here for the first three values 1, 3, 5, they are not repeated. For the next values 6 is repeated and 7 is also repeated 3 times. So for these cases, how to find P of SK means, so for the value 1, so what is the value we are getting? 0.19. So 0.19. Same value will be P of RK and P of SK because it is only one time occurring. And 3 value is 0.25. And next one is 5. Only one time it occurred and its value is 0.21. So 0.21. And here if you see 2 times this 6 has occurred. So how to get this P of SK value? Here we have 0.16 and 0.08. Okay. So what we have to do means we have to add these two. So here if we add these two, we will get 0.16 plus 0.08. We are going to get the value 0.24. So for 6, the value of P of SK is 0.24. Similarly, here 7 has occurred 3 times, and for this 7 we have 0.06 plus 0.03 plus 0.02. The value is here 0.11. So like this, first we have to calculate histogram equalization for this first image. So let us consider this is image 1. So for this histogram equalization is calculated, and from this we should also draw the histogram representation. So we have seen different methods of histogram representation. So in this, how to draw histogram representation means RK, P of RK. So here this is 0 value, RK represents gray level and P of RK is probability. So histogram representation means any image will be represented in the form of graphical representation. So here RK values are ranging from 0 to 7. So here we will have 0, 1, 2, 3, 4, 5, 6 and 7. So P of RK values, we got all this. For 0 we got 0.19. So for 0 we got 0.19, and for 1 0.44, 0.44, and for 2 0.65, 0.65, and for 3 it is 0.16, 0.16, and for 4 0.08, very small, 0.08, and for 5 0.06, for 6 0.03, and for 7 it is 0.02. So like this we have to draw the histogram representation. And so we have performed histogram equalization for image 1. And the next step is, this is image 2 which is given. So what are all the values here given? ZQ will be given and P of ZQ also will be given. So to perform this histogram matching, we have to calculate this transfer function G of ZQ and also the actual value P of ZK. So this actual, to calculate this actual value, first we have to do another procedure. Based on that, we will fill all these columns. Now, so here all these are the values of ZQ, which is representing gray level. So 0 to 7. That means here this value will be Z0 is equal to 0 and this is Z1, Z2, Z3, Z4, Z5, Z6 and Z7. So considering this ZQ and P of ZQ, we have to find the value of G of ZQ. So for this G of Z, so in order to calculate the transfer function Z of ZQ, we have the formula. So Z of ZQ is equal to L minus 1 sigma I is equal to 0 to Q P of Z I. So here this Q will be ranging from 0. So here we can see it is from 0 to 7. So initially let us start from Q is equal to 0. For Q is equal to 0, what is Z of Z0? So whatever we are getting, we have to place in this column. So here L minus 1, as we are dealing with 3-bit image, we have seen in the question, L minus 1 means it will be extending from 0 to 8. Sorry, 8 levels will be there. It will be extending from 0 to 7. So L minus 1 is the maximum value, which is 7. Sigma I is equal to 0. Q is also here 0. P of Zi. So we will have here 7. P of Z0. So here we can see P of ZQ. Q is here. For 0, the value is 0. So here 7 into 0, for Q is equal to 0, Z of Z0 also will be 0. So this value will be equal to 0. Similarly, for Q is equal to 1, G of Z1 is equal to 7. Sigma I is equal to 0 to Q. But here Q is now 1. P of Zi. Like this, 7. P of Z0 plus P of Z1. So here P of Z0 and P of Z1. If you see here, this is P of Z0 and this is P of Z1. Both are zeros. If you multiply that with 7, the result will be 0. So when Q is equal to 1, G of Z1 will be equal to 0. Similarly, we have to find for Q is equal to 2. So G of Z2 is equal to 7. Sigma I is equal to 0 to Q, that is 2 P of Zi. So P of Z0 plus P of Z1 plus P of Z2, as all these values are 0, again for Q is equal to 2 also we will get G of Z2 as 0. Next, coming to Q is equal to 3, to find G of Z3, 7, sigma I is equal to 0 to 3, P of Zi. So here 7, P of Z0 plus P of Z1 plus P of Z2 plus P of Z3. Okay. So P of Z0, Z1, Z2, all these values are zeros, whereas here P of Z3 value is 0.15. So here this will be 0.15. So 0.15 into 7, 0.15 0.15 into 7, the value is 1.05. So 1.05. Okay. Similarly, we have to calculate for Q is equal to 4, 5, 6 and 7. Okay. So if we find when Q is equal to 4, we will get G of ZQ, that is G of Z4 as 2.45, and for Q is equal to 5, we will get G of ZQ as 4.55, and next for Q is equal to 6, we will get G of Z6 as 5.95, and for Q is equal to 7, we will get G of ZQ as 7. Okay. So in the histogram equalization to perform, we have to round these floating point values to the nearest integer. So if we round, this value will be 1, this is 2, this will become 5, and this will be 6, and this is 7. Now, next step, we have to find what is the actual value. To find this actual value, we have to do one step before finding this actual value. From that only, we are going to write all this. What is that step means? SK and ZQ. So what is that SK? SK will be getting from image 1. So here, what are all the values we got here? SK values 1, 3, 5, 6 and 7. So 1, 3, 5, 6 and 7. So we have to write here 1, 3, 5, 6 and 7. Similarly here, what are all the values we got for ZQ? ZQ is for second image. So here if you see ZQ, for which values we got all these ZQ values means, if you see the first 3 values, it is 0. What are the next values here? 1, 2, 5, 6 and 7. So here, there we have to enter ZQ values. So for all these, what are the values here? 3, 4, 5, 6, 7. So here, 3, 4, 5, 6, 7. So after writing this, we have to perform inverse mapping from ZQ to SK in order to find the actual values. So if we perform inverse mapping ZQ to SK, 3 is equal to 1. So 3 is equal to 1 means here, when 3 is equal to 1, what is the value we are getting here? Anyway, here first 3 values are zeros. So we have to write here 0. So when 3 is equal to 1, for SK value 1, we have to see SK value 1. So here, so when SK value is 1, how much we are getting here? 0.19. So that value we have to write here 0.19. So how to write the second value? By performing inverse mapping from 4 to 3. 4 is equal to 3. When SK value is 3, we have to see for SK value 3. So this is the SK value. When SK value is 3, here the equivalent value is 0.25. So here we have to write as 0.25. And what is the next inverse mapping? 5 to 5. 5 means here this is SK value. When SK value is 5, see here, when this SK value is 5, so what is the value here? 0.21. So we have to write here 0.21. And what is the next value? Inverse mapping 6 to 6. Now SK value is 6. We have to see for 6 value of SK. So here, when the value of Sk is 6, what is the value? We have to take average of these two. Already it is done. The value is 0.24. So here we will get 0.24. So coming to the last value, 7 to 7. So when Sk value is 7, we have got these three values. We have to take the sum of these three, which is equal to 0.11. So here we have to fill with 0.11. So like this we have to calculate all the values of P of Zk, which is called actual value. So in this way we have to perform histogram matching. So here we have drawn histogram representation for the image 1. So similarly in this case also, we have to draw the histogram. So what type of histogram we have to draw means, first one is ZQ, Z of ZQ. So here ZQ are the values from 0 to 7. We have to put 0, 1, 2, 3, 4, 5, 6 and 7. Here the values of Z of ZQ we have to take from here. For 0, 1, 2 we have all zeros. For the value 3 we have 1. For the value 4 we have 2. For the value 5 we have 5. For value 6 we have 6, and for value 7 we have 7. So like this we have to represent histogram. Now, so this is how we have to perform histogram matching. So in order to perform histogram matching, first we have to do histogram equalization for both the images individually. So by performing this inverse transform, we need to make histogram equalization. So this is what that entire procedure of histogram matching says. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.